Welcome to the Climate Adaptation Research Symposium. My name is J.R. DeShazo, and I am the director of the UCLA Luskin Center for Innovation. And it's my great honor to welcome you, over 2,000 registrants, to this first of its kind event. This symposium couldn't have come at a more critical time. As I look out over the skies of Los Angeles filled with smoke and ash, with record-breaking fires happening up and down the west coast of the United States. Only 3 weeks ago, we broke all kinds of heat wave records with triple-digit temperatures. And think about the rest of the country and the world experiencing increasingly intense storms, flooding, wildfires, heat waves, where the low-income and vulnerable populations bear these impacts the most. The three objectives of this symposium, I think, couldn't become more relevant than they are today. Our first objective is to continue to identify the impacts of climate change. Who is impacted and how much? Our second goal is to begin to identify resiliency policies and interventions that can lessen the impacts of climate on our communities and evaluate which strategies are not only most efficient and effective, but equitable as well. And our third objective today is to create better connections among you all so that we have a more robust and prepared and capable team of researchers as we move forward to continue to identify impacts and address solutions and craft effective policies. I'd like to thank the symposium's supporters and sponsors, Southern California Edison and Burrell Happold. I'd also like to thank the California Strategic Growth Council for their support. I'd like to recognize the contributions of our organizing committee who selected the 40 papers that will be presented today out of over 150 that were submitted. I very much want to extend my gratitude to the Luskin Center staff, in particular calling out Michelle Einstein and Christian Zarate, who transformed this from an in-person event to a virtual event, a very Herculean task. Thank you guys very much. We hope in the future to make this a recurrent event and to host you here in Los Angeles and be able to dine and socialize, as well as hear great research findings and have intellectual discussion in the future. And so please, as we move forward, let's stay in touch. And if you're like me and having a hard time figuring out which of the 17 sessions to attend today, don't worry, we're going to record those. We're going to share those with you after the event. I hope you enjoyed today's symposium. And with that, it's my honor to turn you over to your session moderators.
Hi, it's great to see so many attendees here. So very warm welcome also from my side. My name is Nora Pankratz. I'm a postdoctoral researcher at the Luskin Center for Innovation, and I'll be guiding you through this session today. So thanks very much for tuning in, and we're excited to have you at the Climate Adaptation Research Symposium. Before we get started, maybe let us quickly mention all of our collaborators who have made this day possible. So big thank you on that note. Yeah, and with that, let's go over to what we have on the agenda for today. So this session is all about, oh, first of all, let's cover some housekeeping items. I skipped one step here. So yes, so I hope you're already a little bit familiar from tuning in here with the widgets that are available and this conference tool that we're using here. So you can resize little windows that you're seeing here, and there are a couple of controls that might be helpful to be familiar with. So the first one is if you want to change anything on the window size, just drag the bottom right corner of all of the small windows. And one thing that I think is very important and a tool that I want to encourage you to use is the Q&A icon. So if you have any questions coming up during the presentations, please just post them there and we'll try go through all of them after the presentations. And again, if something comes up, please feel free to make use of that. I think it would be great if we make this as interactive as possible. Finally, there's like a little link to the abstract. So if you want to get back to the big picture view of the project, then that might be helpful. And lastly, if there's any help needed, then just click the question mark icon. That's the way to get technical help. All right, but with that, let's get back to, so this session is all about managing and adapting to climate-related flood risk. And we'll see presentations about 3 different aspects on this note. So first of all, we have Joakim Weill from the University of California, Davis, and he's going to tell us more about the determinants of the uptake of flood insurance. Then second, we're going to hear from Renato Molina from the University of Miami about pricing of adaptation investments in real estate. And finally, Christoph Schiller from Arizona State University on floods and heat waves and the adaptation of flood. So very excited to hear all of your talks, and I would say with no further ado, let's get started. Joakim, the floor is yours.
Thank you very much, Nora, for the introduction, and hi everyone. Today I'm going to be talking about flood insurance and in particular flood maps. This is very much a work in progress and comments are very welcome. So floods are very frequent in the United States, and they are also expected to become a lot worse, with damages to properties and infrastructures exceeding billions of dollars per year. It's going to become worse not just due to sea level rise and storm surge on the coast, but also due to more intense local precipitation events, for instance, like last year in Tulsa, Oklahoma. There are trillions of dollars of properties that are at high risk of flooding. To cover these risks, flood insurance in the United States is provided through the National Flood Insurance Program. It's a federal program that provides about 95% of all active flood insurance policies. And that covers about 5.5 million properties nationwide. However, these numbers are still very low, and recent work on the estimation of flood risk find that there could be as many as 3 times more properties that are exposed to very high risk of flooding. This deficit of flood insurance coverage is even more surprising, considering that flood insurance is typically subsidized and only costs a fraction of what would be the actuarially fair price. And on top of that, there is also an insurance mandate in place in the 100-year floodplain, as shown on the FEMA's flood map, and we will dive into more details into this floodplain right after. Low insurance coverage is problematic because there is some work showing that flood insurance increases the resilience of communities when they are impacted by flooding. And there was even a further decline in the number of policies enforced by 500,000 in the recent years. So the functioning of the National Flood Insurance Program is closely tied to flood maps, which are developed in partnership between FEMA and local communities. And these flood maps provide a lot of information about flood risk. But what is going to be of special interest to us is that these maps highlight different floodplains. Here I looked up the map for UCLA. You can see the Luskin School of Public Affairs here. In light blue is depicted the 100-year floodplain, in which you have a 1% chance or higher risk of flooding in any given year. And in orange, the 500-year floodplain with a lower chance of flooding. There can flood anywhere, but flooding is much more probable to happen in the 100-year and 500-year floodplains. And these floodplains depicted here are super important because they will be used to set the price of flood insurance. And if you live right there in the blue area, the 100-year floodplain, you're going to pay a much higher price for your premiums than if you were living right outside of it. In this specific case, there is nothing tragic about high insurance prices because to the left of the 100-year floodplain, you have the Bel Air Country Golf Club. And so homeowners located in this area can probably afford high insurance prices. There is also an insurance mandate in place. If you live in the 100-year floodplain and you have a federally backed mortgage, then you are required to purchase flood insurance. These flood maps also provide risk information to homeowners and renters, and they are used to inform urban planning. However, these maps are also heavily criticized, first because they can be subject to manipulation, and here you can see that the incentives are in place to reduce the extent of the 100-year floodplain, since the 100-year floodplain increases insurance premiums and can restrict urban planning. But also because these maps are said to be often outdated. And this is despite the fact that billions of dollars have been already invested to update these maps. And since Hurricane Katrina, more than $2 billion were invested to digitize the previously paper-based flood maps. Here I'm showing a picture of Davis in California, where I live. On the left, you have the paper-based map that was in force starting in 1979, which was updated to the digital map on the right in 2010. There was no underlying change in the extent of the floodplains on these maps, but now the new flood maps are much easier to use because you can just type in your address and it will directly show whether you are in the 100-year floodplain or outside of it. There are still more than 50% of all current flood maps that are considered outdated, and the Association of State Floodplain Managers estimate that it would cost more than $4.5 billion to update these maps. So can the modernization of flood maps increase flood insurance take-up rates, which is one of the big reasons put forward to update these maps? Quick preview of the finding, we'll see that it could increase insurance take-up rate, but so far it hasn't. And this is in large part because the new flood maps reasoned more than 3 million individuals outside of the 100-year floodplain since 2005. In aggregate, the digitization of flood maps even led to a decline in the number of policies in force of more than 100,000 policies. I use several sources of geographic data. First, I used a digitized version of the FEMA's flood maps that were effective in 2005 in about 1,300 counties. And I compare these maps with the all current and archived FEMA's digital flood maps since 2010. And what this does is that this allows me to keep track of changes in the definition of the underlying 100-year and 500-year FEMA floodplain. Finally, I overlay these with a population layer of the United States that will allow us to see whether more people were rezoned inside the floodplain or outside of it. It's important to note that for this part of the project, I take the population as fixed. I only use the distribution of the population as of 2010. So this will be net of any spatial sorting that may occur. And I look at spatial sorting in different work, but it seems to be limited and confined to specific areas. To get a sense of the temporal and spatial variation in the treatment, here you can see all the census tracts that got a digital flood map. And these are located all over the United States in most flood-prone areas. And today there are about 50,000 census tracts that have an updated digital flood map. Okay, so what did this digitization do to the underlying floodplain? If we zoom to here, Broward County in Florida, you can see the old flood map that was paper-based and in force starting in 1997 on the left. The 100-year floodplain is again depicted in light blue, and the 500-year floodplain is depicted in orange. And on the right, you see the new map that came out in July 2014. And you see that there was a massive rezoning of neighborhoods outside of the 100-year floodplain. All these areas that turned from blue to orange correspond to a reduction in nominal flood risk. If we go to New Orleans in Louisiana, there's a bit the same picture that emerges with a lot of the blue areas that have been transformed to orange areas, so reduction from the 100-year floodplain to the 500-year floodplain. And you also see these pink areas that correspond to areas characterized as outside of the floodplain because of new levees and drainage system constructions. So every single community in the US has its own important story. And on this map, I just colored in red the census tracts that tended to rezone individuals outside of the 100-year floodplain, and in blue, those that rezoned individuals toward the 100-year floodplain. And you see that you have rezoning in both directions everywhere. However, when you aggregate the numbers up, we find that digitizing the flood map tended to reclassify a lot of people outside of the 100-year floodplain. The 3 states that reclassified most people outside are Florida, California, and Louisiana, together responsible for like 2.5 million people exiting the 100-year floodplain. Whereas some states added people to the 100-year floodplain, but in smaller comparative numbers. So in aggregate, there are more than 3 million people that were rezoned outside of the 100-year floodplain, but it's not clear what this would do to flood insurance. It could either increase flood insurance take-up through a price effect, because if you're rezoned outside of the floodplain, your insurance is now cheaper, so this would lead you to increase your demand for it. But it could also reduce the demand for insurance due to information, if you now believe that your house is at less risk of flooding than it was previously based on the paper-based map, or if the mandate requirement in the 100-year floodplain was binding and now is not, because it's not a 100-year floodplain anymore. So to get at that, I merged the previous GIS data with all data on FEMA flood insurance policies in the past decade. That I collapse at the census tract month level, mostly because the FEMA data is not geolocalized. And I use a standard 2-way fixed effect model with census tract fixed effect, month fixed effect. A digital map is a dummy that will switches on once the census tract receives its flood map. And I interact that with a variable that keeps track of what the rezoning did on average in the census tract, whether the digital flood map tended to classify more people in the floodplain, in the 100-year floodplain, or outside of it. When you run this model with, as an outcome, y, the log of the number of policies at the census tract level, you see that the effect tends to be small and positive overall, but that it is strongly differentiated based on whether the new flood map rezoned people inside the floodplain or outside of the 100-year floodplain. In places where the digital map tended to rezone people towards the 100-year floodplain, there is an increase in the number of insurance policies of 15%, whereas there is a decline of the number of policies in force of 25% in places that decrease the extent of the floodplain. So this is nice to give some insights into the impact of this digitization on flood insurance, but recently there has been a lot of work basically telling us whatever you do during the pandemic, do not run this type of 2-way fixed effect models if you have some variation in the treatment timing, which I have here. And these work propose alternative estimators that unfortunately do not really work in this context for reasons that we can discuss. But on top of that, the policymakers may not necessarily be interested in an average treatment effect of digitization nationwide, and they might care a bit more about what happens to their specific communities. So to get at that and really get at the heterogeneity of the impact of digitization, I use an approach based on synthetic controls. Very quickly, a synthetic control, I will construct weighted averages of untreated census tracts that do not receive a treatment, that do not receive a new digital flood map, to serve as control units for the census tract that do receive a digital flood map. This is an approach that is commonly used when only a few units are available, such as countries or states, but here I will estimate a distinct census tract, a distinct synthetic control for each of the 12,000 census tracts that receive a flood map during my observation window. I'm showing 6 of them here. So the solid line is the evolution of the number of policies in a given census tract, and the dashed dotted line is the synthetic control that is that I estimated for it. The treatment effect of the policy of the impact of digitization on take-up can then be estimated just by taking the vertical difference between these 2 lines. If we plot these vertical differences as points, this is the picture that we get. So each point here is the treatment effect estimated after 2 years for a given census tract. I regroup them based on whether they occurred in census tract where digitization led to people classified outside of the 100-year floodplain in the top panel, or towards the 100-year floodplain in the bottom panel. And there is a bit the same picture that emerges, that place when you had rezoning outside of the 100-year floodplain in the top panel, you see a lot of negative treatment effects that tend to occur here for places that had initially a large number of insurance policies in force. We can again aggregate these effects to get a total treatment effect on the treated, conditional on rezoning outside of the 100-year floodplain, and we see that this effect is very negative and is only partially offset in aggregate by the places that rezone properties towards the 100-year floodplain. What is really nice with the synthetic control and pretty cool is that you can really get to understand what happens more locally. So here, these are all the treatment effects represented on a map, with negative treatment effects in red and positive treatment effects in blue. And if you zoom in on specific areas, for instance, here, the area that was recently impacted by Hurricane Laura, you see that the digitization of flood maps led a lot of census tract or neighborhoods to increase their demand for insurance take-up in blue, with dots proportional to the magnitude of the effect. But there are also places where you see clusters of negative treatment effects from the policy. And here I zoomed in on New Orleans, and you see that a lot of places in New Orleans strongly decrease their demand for flood insurance following the digitization of the flood map. So summing up and putting everything together, we see that there was a large insurance coverage deficit when Hurricane Katrina hit 15 years ago, which many attributed to flood maps being outdated and not conducive to insurance take-up. However, the new digital flood maps led in many cases to further reductions in the demand for insurance, especially in places that tended to rezone properties outside of the 100-year floodplain. And this suggests that the insurance mandate requirements and the information signal sent by the 100-year floodplain together have a greater combined effect on demand than insurance prices. I'm working on separating these different effects and assess the magnitude of the insurance coverage gap based on independent flood risk data. Great. Thank you very much for your attention.
Thank you for your talk, Joakim, and that was perfect time management. Great. Okay, I can see, so we have one great question in the chat already, but I can see we have a really diverse and large audience, so please don't be shy and add your questions. But let's start off with the first one. So this is a question from Bridget Rothgren from the Federal Reserve Board. And she's asking, so given the potential for manipulation of the FEMA flood maps that you raised at the start of the presentation, could you say more about what the potential endogenous reasons are for reclassifying homes out of the 100-year floodplain, and how we should think about that and what we can then learn from the results? And she also gives an example. So that is, for example, in communities where people have stronger preference against being required to buy insurance, would they also push harder to be reclassified?
That's a great question. And so if you're a homeowner, there's basically all the incentives are for you to be out, for the zone to be classified as outside of the 100-year floodplain. Because if you're not in the 100-year floodplain, you can still purchase insurance. It's still available to you when you're reclassified outside of it, but you're not required to buy it if you didn't want to. And also, if you do end up buying it, then insurance is much cheaper. And I ran some models at the property levels on houses that were reclassified from the 100-year floodplain to outside, and I observed a decline in the insurance premium of about $250, $300 per year, which is about a third to a half of the annual price of flood insurance. And then for local urban planning, then urban planning is much more constrained and limited in the 100-year floodplain. So there could also be incentives to reduce the extent of the 100-year floodplain to allow for new developments.
Great, thank you. Yeah, the Q&A is still quiet, but we have some time left, so we have 4 more minutes for questions here. Maybe we'll just give it a moment. If there was anything that came up, then please shoot. Great, so actually we have a couple more. So one question is referring to the conclusion slide. So what does price response refer to exactly?
Yeah, so these are not results that I'm showing here, but when your house is reclassified from the 100-year floodplain to outside of it, or the other way around, when we reclassify towards the 100-year floodplain, the price of insurance is going to change. And I know that, so there's a lot of work that focuses on the price of the house itself, but here I'm really concerned about the demand for flood insurance, and so I'm thinking more about the price of about the premium of the insurance.
Great, that's also helpful to clarify. Then we have 2 more. So first of all, Hannah Henninghausen is from the University of Alaska, and she asks, to what extent have you considered recent increases in insurance costs for previously subsidized properties? And do you believe there's any relationship between homes that were rezoned and those that were pre or post firm?
Yeah, this is a very good question, and it's definitely something I can look at in the data. So during the time period that I consider, there is 2 major federal laws that change the price of insurance for previously subsidized properties, the Bigger Waters Act and the Homeowner Flood Insurance Affordability Act. And they do tend to increase prices for a subset of properties and reduce demand in these areas. But I account for that in the synthetic approach estimation. And what I find is that on top of these reforms that did lead to a decline in the demand for insurance, there is also a strong decline that occurs because of the additional digitization of flood maps. For the second part of your question, I haven't looked at it yet to look at whether there is a relationship between the rezoning and places that were where you see a lot of houses that were classified as pre or post firm. But I think that's a great idea, and thank you very much for it.
Great, thank you. And now this works really well, so we hope we keep that up for the next presentations. Lots of questions, and I think the ones that we cannot answer now, we'll still have them here on the Q&A and can pass them on to the speakers. Maybe one last one before we move on to the next talk, and that would be a question by Curtis. And that's the question, do most flood maps assume stationarity? So unchanging conditions, no sea level rise, and so forth. And if so, how can changing conditions be better captured in maps?
This is a great question, and this is one of the issues with these flood maps. So they are designed to account for flood risk at the time when these flood maps come into effect. But conditions are changing rapidly, and flood maps will become outdated just because of that. FEMA is supposed to update and provide a new flood map at least every 5 years, but it's a very expensive and complicated process to perform, and so far it hasn't been able to do that. But there's also some work that showed that providing a new flood map can take years of work, and so by the time the new flood map comes out, it's almost already outdated. Which makes it really hard for the flood map to actually depict changing conditions.
Great. Once again, thank you very much, Joakim. And with that, I'd say we move on to, actually, I'll skip through the appendix here.
Yeah, I had a lot of maps for California.
A lot of content ready for us, so that's really great. Thanks again. And with that, I'd say we move over to a presentation by Renato Molina. So he's an assistant professor at the University of Miami with both appointments at the Rosenstiel School of Marine and Atmospheric Sciences and the Herbert School of Business. And with that, I'd say, Renato, the virtual floor is yours.
Thank you. Thank you. Thank you everyone for being in this session, and also thank you for the invitation. This is a project. It's a collaboration with David Kelly and it's fairly early stages. So if you have any feedback, I would really appreciate that. So the name of this project is Adaptation Infrastructure and its effects in proper values in the face of climate impacts. And as many of you may know, we are facing some of these climate impacts already. So here I have a picture of a street in Miami Beach, and this happens fairly often whenever we have excess rain or when we have a king tide, right? So what we know so far in terms of how climate affects the Earth and what are those changes implying for the general public, well, according to no estimations, we know that the global temperature has risen by about 0.9 degrees Celsius, but the effects of those mechanisms or that change translates into more severe and more frequent flooding events, and also more extreme storm surge events whenever not only have usual storms, but also in the face of hurricanes. So then we're faced with the question, how can we face this problem? Because if we talk about climate mitigation, then the potential effects of mitigating climate change will take place way long into the future. So what can we do now? And then the answer to that question, obviously, comes in the face of adaptation. So this is fairly close to the place where I live, and it was basically a project in which they said, we need to raise these streets. They're getting flooded all the time. So we're going to install a few pumping stations. We're going to raise the streets, and we're going to be good to go for the next 20 years. I hope so, right? So this is taking place in many cities or many urban centers, basically, that are exposed to this type of risk. But then we don't really know what are the effects. Are the public actually aware of this is going on? Are there any secondary or tertiary effects when it comes to how people make decisions regarding settling in those places, regarding investing in those places, etc.? So one of the things with adaptation is that it's very attractive with sea level rise because it's an engineering-friendly approach, right? So you're going to have a few properties at risk, so you can basically dump a bunch of money and you will get your engineers and they will build you a seawall and that will protect those properties. So it's a basic notion of what works. Well, we can build stuff and protect these properties. So in theory, if we get this right, we could save about $900 billion using adaptation, just deploying infrastructure where it's needed, either in the form of fully raising property level or installing seawalls, etc. The problem with that idea is that it requires a lot of information, and we need to be able to predict what are the effects of climate change in general. But here's the problem with that, is whenever we think about a group of people at risk, and then we think of an adaptation measure in order to control for that risk, what happens is usually is a lack of funds. People are usually resorting to not in my backyard approach. I don't want that seawall. So for instance, I live right on the water, and if you ask me, do I want a seawall right in front of my property? I would say, well, not really. It's not gonna be in my best interest to have that there. But then again, that's just from my own perspective, right? If I'm a social planner, then I have to consider those individual perspectives, but also the social value of installing infrastructure. And that becomes a very tricky process when it comes to managing risk and also managing a city. And there's also this notion of that I will hope that most of us are familiar with, which a poor risk perception when it comes to yes, there is sea level rise, but is it really going to affect me in, like the timeline that I care about? Is it really going to affect this house that I'm only planning to own for 5 years? Maybe yes, maybe not. And if the answer is not, then I don't care about adaptation. And that's more or less the argument. And we want to know is any of these are any of these efforts actually being captured by the public? Do they work? Well, and to answer that question, we basically are going to look at Miami-Dade County, and we're going to examine how different adaptation infrastructures deployed in the county this year reflect into the house, the market for real estate. And this is somewhat useful because you could say that people transacting properties basically are internalizing the effects of infrastructure into the price of their properties, and people that are buying are doing that as well. Then, based on those estimates, we'll also try to come up with a notion of, are any of these ideas of these projects actually useful? Do they pass a cost-benefit analysis? Which was one of the main questions that I asked before. Is this too expensive? Because when it comes to planning for these things, and every time we talk to city planners, they basically face the same question. Okay, so do I raise this street for these really rich houses, or do I come up with a project in which I can help homeless people, right? So we're trying to contribute to this dialogue between both people that are concerned about climate risk, property owners, and city planners via what we can say of the past adaptation projects, at least in Miami-Dade County. So to do that, we collected a bunch of data. So we went to all of the office buildings that work on this thing, and we basically dug up all of the records for transactions, and this comes from appraisal data for Miami-Dade County, so we can observe a battery of observables for each property, which will allow us to say something more robust regarding our analysis. And then we also went around and dug up all the data regarding infrastructure, which was aimed to solve problems of flood and surge. And even though we collected a ton of projects, we're going to focus our analysis between 2000 and 2018, because that's where we get most of the good information regarding the projects. So in total, we end up with a little bit over 200 infrastructure projects that target either flood and surge. And we're going to try to say something about how installing a project basically affects the property values of those transactions nearby where the infrastructure was deployed. So in total, we're gonna contrast those infrastructure projects with 430,000 different transactions. So just to give you somewhat of an idea of what these things look like. So on the left here, I have a map with all the projects that we were able to collect. And some of them are just aligned, meaning that's a street that is being treated. Some others are points, meaning this is probably a pumping station. And then we have polygons, which are basically treatments that cover an area, right? And we have several ways to control for those different characteristics of a project. And then on the right in this other map, what we have is basically all of the transactions that we can observe for this county, right? So there is somewhat a nice variation when it comes to where these projects are located and how many transactions we are going to be able to observe. And just to give you an idea of what these projects might look like, here I'm showing you a picture of this place called North Bay Village. So there are about 30 items for a project that was put in place in this little island, right? And those include seawalls, drainage wells, stormwater outfall, pumping stations, bay restoration, and power line relocations for the entire island. So in order to codify those projects into something that we can work with, we have to go read the files and basically create a list of things that will be useful for us when it comes to analyzing this idea. So I wasn't really sure about how technical this presentation was going to be. More than happy to talk about any of the estimation details with you, but for now, I just want to give you the results, and more importantly, I would like to somewhat make a hint to the implications of it. Right, so the basic idea of our analysis is basically we have variation when it comes to treatment, and Joakim mentioned that there might be some problems when it comes to heterogeneity in the timing of treatment, and we do have some ways to control for that. It's not perfect because there are fundamental problems with the estimation when you have heterogeneity in the timing of treatment, but we do have some ways to reduce that, focus on places that are only treated once. And the results are robust. So in general, what we can say from this is that the real estate market reacts to adaptation infrastructure, and the way in which they react is basically there is an observed increase in price that varies between 7 to 8% for nearby properties, right? And this is after we control for everything that we can see and for local trends in the market for real estate. One of the things that is interesting, however, is that this valuation or extra value associated with these properties nearby a project is it takes 1 or 2 years to basically capitalize. And our theory is that that happens because, okay, you are not really sure if that pumping station that was installed around the corner basically helps you, right? Once it does, and that will take a couple seasons of rain and maybe a storm passing by in order to capitalize. And we see that being a consistent result. And then it fades away with distance, and also it fades away with time. So after 10 years, basically, all of the value added due to having an adaptation infrastructure installed near you goes away. So those are very, very interesting results. And one of the things I'm happy with is that they make sense. Meaning, yes, if you install something right near my house, it's not necessarily going to affect me right away, but it might take some time for me to actually realize how useful that seawall or that pumping station or that raised street is going to be to my own property. But then after 10 years, I forgot about it. So then with that result, then it comes a more interesting part, at least for us, which is to say, okay, all of these make sense. People have said that before. And if you're somewhat conscious of what the risks are, which you could maybe argue that people in Miami are facing flood all the time, so they're very aware of the risk of flooding, and so they appreciate when a measure controls for that risk. Then the question is, okay, so is it worth it? Should I just buy out all this property and let it, turn into reef habitat? And then to do that, we basically project these changing prices, and we do this by looking at each project and basically looking at all the transactions nearby and applying that change. And we also observe the characteristics of the project, not only in terms of what the purpose is, but also its cost. We can have somewhat of a notion of a cost-benefit analysis that includes the potential benefits of the infrastructure and the costs associated with each project. And if we do this analysis, basically, we get that the mean benefit for a given project, well, it depends, right? So it depends on where it's going to be, and it depends on its purpose. So some projects actually have negative benefits. Some projects were way too expensive and they cost no benefits that were measurable in terms of property transactions. Maybe they had other benefits that we're not able to observe, right? But overall, what we can say is that the mean benefit of a project is about $190 million, and the overall benefits of the projects from 2000 till 2018 is about $3 billion net, right? So that's all good news. If you are in support of adapting, it might not be good news if you're not a fan of subsidizing other people's risky behavior. So just to conclude, we can basically say a few things. One is, according to our data and according to our analysis, it looks like adaptation efforts do not go unnoticed, which is a good thing, right? At least, however, in Miami-Dade County. And this is a very particular type of real estate market. So we're not really comfortable spending these results to other areas where people might not be that aware of what sea level rise entails, what the risks are for you. But at least from this sample, we can say that people do pay attention to this type of measures. The perceived benefits, at least the ones that are capitalized by the real estate market, make adaptation a sound public policy, at least in the aggregate. Am I saying that all adaptation projects pass a cost-benefit analysis? Not really. Many of them actually happen to be negative. But the case I'm trying to make here is that, at least in average, they have a positive value, and the total aggregated cost and benefit analysis also passes the test. So one of the things that is important to highlight here as well is that because you have this time trend pattern, it tells you that you have to also adopt a dynamic approach to adaptation, right? Adaptation cannot just be just a one deal and you're done. It has to be dynamic, and that we think is also reflected in the way the effect of the effect that we measure behaves. So I hope I'm not over in time, and thank you so much. And any questions and comments will be very much appreciated.
Great. Thank you so much, Renato. Again, please don't hold back. As Renato said, any question, comments are very welcome. We have 2 already in the Q&A, so maybe we just get started, but we might have time for more. So first of all, Bruce Jensen from the Alameda County Planning Department has a question, and I think it refers to other non-market outcomes related to these investments. So he asked, do engineering solutions take into account other effects on local biological habitat? So for example, near the San Francisco Bay, if you put in seawalls, that would mean that there would be serious modification to tens of thousands of acres of bay shorelands, and those are critical for regional and Pacific flyway resources. Yeah, so your thoughts on that would be great.
Yeah, thank you for that question. Actually, sometimes they do, sometimes they don't, right? So actually, I'm involved in another project which is trying to bring that perspective, which we think is very much valuable in terms of whenever you have an infrastructure, it cannot be set upon just using the criteria of is this going to protect properties or not. It should also take into account, you know, like, oh, what is the environmental impact? Is it going to be better? It will be better, you know, if we have an infrastructure that doesn't cause any harm, but actually improves the environmental conditions for local biota and local fauna, but even water quality in these type of cases. So yeah, I think what happens often, and I'm not saying this is the case for all of the projects that are taken over by the Army Corps of Engineers. It's the idea is you will have an environmental effect and then you do some mitigation. Sometimes that mitigation brings back to like the baseline level. Sometimes it doesn't. So, I mean, I would like to see a much more comprehensive approach to infrastructure in the future. That's for sure.
Great, thank you. 2 more questions, and I think both of them refer to the specifications. The first one would be, do you control for the type and number of adaptation projects near a property, or is it just a 0-1 indicator at the moment within this distance of the project? Yeah. Yeah, so for one of the, yes, that's great. So right now, the way it's set up is basically we have 2 categories. We have flood and surge. One of the main problems that we have, and I imagine this is going to be true in every case, is that projects do not necessarily serve just one purpose, right? So for instance, if you have a pumping station, that's going to help you if there is a flood event or if there is a storm surge. If you have a seawall, that might be able to protect you in terms of sea level rise, but also when there is a storm surge event. So all of those things are basically confounded. So the best way we found to deal with that problem was basically create categories. So we read the descriptions of the projects, and based on what the engineers declared the purpose of the project was, we had checks, right? So we had sea level rise, flood, surge, and sewage, and we had several marks, and basically the clearest definitions that we could find were flood and surge, and those are the projects that we treat. So we evaluate
basic combinations that we have for those type of projects, which will be purely flood and then flood and surge.
Perfect. Okay, I forgot if I mentioned, so there was a question by Adam Pollack. Next, one last question, although we have more in the chat and keep them coming. Again, I can follow up on these questions later on. One more question by Jacob Brad from Harvard University. And it's a question on whether there would be any reasons that we should be concerned about the indigeneity of these investments in the capitalization of estimates. And yeah, what you so he wonders what you think about the process that is used to select these investments. Might be helpful to know more about that.
Okay, yes, this is definitely one of the main concerns. So there are basically, like when it comes to the estimation, there are two concerns, right? One is how endogenous is this problem, and then the second one is are the effects that you're measuring actually true? Are they correlated with anything else that happened either before or at the time of the completion of the project? So when it comes to the endogeneity, what happens is there's definitely a concern when it comes to, you know, like, are there any factors driving where projects are located at? And we are aware of those. One way to control for that is, again, using different approach in which you make an assumption relative to what the trend is for treated and untreated units, and if it satisfies the parallel trends assumptions that by your identification. But then again, there is a problem when the treatment, the timing of treatment varies. So that's definitely a concern that we try to address as best as we can. The other issue that we basically look very hard at is, are there any pre-trends associated with the effects that we measure, and we find no evidence that there are pre-trends. So yes, this is tricky. One of the things that I think might be useful for us is they have, whenever we talk to the authorities, they basically have a ranking system. So basically they have this little table where they basically have how much capital is at risk and what is the probability of losing that capital. So they make these calculations and they make decisions based on yearly budget. We have tried to actually secure that ranking so we can get more fancy when it comes to our analysis and try to do a regression discontinuity design in terms of what happens with those neighborhoods that almost got a property, an adaptation project, but we have been so far unsuccessful. Maybe in the future.
Great, thank you very much once again. And with that, let's move over to the next presentation that we have on the agenda. So again, I'll just flip through here, the appendix here. There we go. So next up, Christoph Schiller, Assistant Professor of Finance at Arizona State University, the W.P. Carey School of Business. Christoph, over to you.
All right, thank you very much, Nora. Thanks everyone for joining. Thank you to the organizers for putting this paper on the program. This is joint work with Nora Pankratz, who happens also to be the chair of this session, and I promise that's purely a coincidence. So in a little bit of a departure of what we've heard from the other two presentations, this is going to focus on climate change adaptation, not so much at the individual household level, but more looking at firms and the types of decisions corporations make. So as we have all kind of seen over the last couple of months with the coronavirus, disruptions to supply chains, to global supply chains in faraway places can have major disruptions and major effects on firms abroad in other places simply through the indirect exposure through this global supply chain link. And in this paper, we're not looking at coronavirus. Instead, we're looking at disruptions to supply chains through climate change risks. And in particular, we're going to be looking at climate change disruptions from floods. That's the topic of this session, but also heat waves. I mean, this analysis is motivated by the fact that CEOs and practitioners already seem to be recognizing this as a major concern. A majority of CEOs, when asked about sort of risks to their operation, identified supply chain risks due to climate change disruption as a primary concern. And that's really not all that surprising, given the fact that a lot of global supply chains nowadays are very integrated, are very tightly integrated, operating with low inventory and just-in-time production. And the important thing about climate change relative to other types of disruptions, other types of supply chain disruptions, is that we can expect these trends to only become more important and more frequent and more impactful in the future. And so this is why we decided to focus on this topic. And so let me give you a little bit of an overview of what we're trying to do in this paper and a quick preview of the main results. So we're really trying to ask two closely related research questions here, where the second one is really our main focus, our main research question focusing on adaptation. So first we're asking if firms have a financial incentive to make adjustments to their supply chains due to their indirect exposure to climate-related shocks and climate-related risks as a result of their supply chain network, as a result of their production network globally. And then after answering this question, we're going to our main research question, which is, do firms recognize these risks and do they take them into consideration by adjusting their supply chains, by adjusting which suppliers they procure inputs from? To give you a quick preview of the results, we first document that indeed there is a direct effect of both heat waves and both floods and to a smaller extent heat waves on financial performance of the supplier firms themselves. And this effect spills over and propagates through these supply chains to the customers as well, to a smaller degree, but to a measurable degree. So there is sort of an incentive to react for these customer firms. And we do find in our second part of the analysis that that's exactly what customers do. If the suppliers are exposed to climate-related shocks in terms of floods and heat waves to a degree that is higher than what could have been expected from a benchmark period before entering the supply chain relationships, then these relationships are much, much more likely to be terminated in the following year. And we observe that these suppliers seem to be replaced by other firms, by other suppliers that have a lower exposure over the same period of time to climate shocks, heat waves, and floods. All right, so let me take a minute to talk about the data that we're using in this project. Really, what we're doing is we're combining sort of three different building blocks of data. First, we have to identify the existence of these types of relationships, these types of supply chain links. What we're using for that is data from FactSet Revere, which is collected based on firm disclosure items, 10Ks, 10Qs, 8Ks, press releases, and so forth, to give you a bit of an overview or an impression of what this sample looks like. This is sort of the geographical distribution of the suppliers in our sample. So naturally, given the fact that this data is constructed from disclosure requirements, we have better coverage in more developed markets where the disclosure requirements are higher, but we do see that the coverage is fairly global, with a lot of firms also from South America, from East Asia, from Southeast Asia, with a broad sort of diversity of different regions. The map for the customers would look pretty similar if I showed you that one. Second, we're combining this data on supply chain relationships around the world with data on climate hazards and climate-related shocks that occur in the locations of the supplier firms. And so what we're focusing on specifically are heat waves and flooding incidents, because both of those types of shocks are closely related to climate change and can be sort of projected out in the future as things that are going to increase in their frequency and impact going forward. So we obtained data on floodings from the Dartmouth Flood Observatory and on heat waves from ERA Interim, and we're matching that to the locations of the supplier firms, focusing on supplier firms that are sort of regionally concentrated to make sure that the types of shocks that we identify are actually occurring in the locations of those supplier firms. And then last, we're combining this. Sorry, this is a quick overview of what the flooding data type of looks like from Bangladesh. So the red regions would indicate those areas, those parts of the map that are flooded in the particular time. And then last, we're combining this with measures of firm performance from Compustat Global, looking at things like revenue and operating income to capture the financial impact of these types of shocks. All right, so let me move to our first research question. Is there a financial incentive to customer firms to make adjustments to their supply chain relationships due to this exposure to their suppliers and the climate risks at the supplier locations? And you can think about this as two alternative hypotheses. First, if customers are able in their production network to sort of hedge against these risks, have multiple different suppliers, for example, or if the suppliers are the ones that absorb 100% of the costs that are caused by these disruptions, we don't expect to see any kind of financial impact on the customer firms. On the other hand, if at least some of these costs are passed on in one way or the other to the customer firms, we should see an impact on the financial performance of the customers in our sample. And the way we test this, the way we estimate this is using sort of panel regressions at the supplier, customer, year, quarter level. So on the left-hand side, we have measures of customer firm performance. On the right-hand side, we have our main variable of interest, which indicates the occurrence of a climate-related shock, heat wave, or flood in the location of the supplier firm. We saturate this model by adding supplier by customer by quarter fixed effects. So that not only takes out any time invariant characteristics at the supplier and at the customer level, but also any type of seasonal trends due to the quarter and any type of interaction of that is sort of location specific seasonal trends. We also put industry by year fixed effects in there to take care of any industry trends and other controls that are typical in the literature inspired by Barreau and Sauvagnin. Let me give you an idea of what the result looks like. So this is a session on floods. So I'll present here quickly the result on the floods. The one on heat wave looks quite similar, although weaker, given that these shocks are typically weaker. What we find is that first of all, we find a large direct effect on suppliers that's not shown here. And we also find a significant negative effect of the occurrence of these floods in the locations of the supplier firms on the financial performance, looking at revenue, looking at operating income of the customers in the following 3 quarters. The effect on the customers is about half in terms of the magnitude relative to the direct effect on the supplier firms themselves. Again, the effect from heat waves is smaller and a little bit less precise. We find similar effects if we collapse this and look at this in different ways of constructing the sample. We also do placebo tests where we look at relationship years in which the relationships between suppliers and customers did not actually exist and don't find effects here. So to summarize this first sort of result, what we do find is evidence for this hypothesis that indeed some of the costs of climate-related shocks in the supplier locations are borne by the customers, which gives the customers an incentive to make adjustments to the supply chain relationships. And that's bringing us to our second main research questions. Do firms actually make these types of adjustments in their relationships? Again, we can look at this as 2 alternative hypotheses. If indeed these relationship-specific investments that customers make to be in the relationships with suppliers are very substantial, it would take a lot of adjustment. It would take a lot of costs to sort of switch to a different supplier. We would not necessarily expect them to make changes. If the costs of sticking with a certain supplier outweigh the costs, the benefits of sticking with the supplier, then we might expect changes to these supply chain relationships. So let me run you really quickly through the intuition that we have in mind thinking about this type of test. So if you assume and if you believe that the managers have a certain amount of information when entering these supply chain relationships, then you would assume that managers of the customer firms already are kind of aware of the probability of climate shocks occurring at the supplier locations and would take this type of information into consideration when entering the supply chain relationship in the first place. So we can observe what is the amount, what is the frequency of these types of shocks occurring in the supplier location before the initiation of the supply chain relationship. And following sort of standard economic logic, you would expect the customers to trade off the benefit and cost of getting inputs from a certain supplier maybe the supplier is very good and very cheap, but on the other hand, there's a high probability of supply chain disruptions, and the customer manager would trade these types of benefits and costs off and enter the supply chain relationship based off of that endogenous outcome. And so any type of disruption, any type of climate-related shock that occurs in the location of the supplier firm that is within the expectations of what the customer could have expected going into this relationship would not necessarily predict that there's any adaptation or any change to the supply chain network, because this is sort of within the cost-benefit trade-off that the customer would have made entering the supply chain relationship in the first place. But as we know, climate change can sort of alter the frequencies, the occurrence of these types of climate shocks in the locations of the supplier firm, and that can over time render the choices of suppliers suboptimal if it starts to sort of deviate from what you could have expected coming in. And this is exactly the basis for our test. So how do we operationalize this? We implement this in sort of simple linear probability models of the following form. Our outcome variable on the left-hand side is an indicator that indicates whether or not the supply chain relationship ended in the following year. And our main variable on the right-hand side is an indicator variable that measures if the number of realized climate-related shocks in the location of the supplier firm exceeded what could have been expected going into this relationship from a benchmark period before the supply chain relationship started. And we again saturate this with fixed effects and controls to try to isolate the effect of that. And what we do find, first of all, here for heat waves is that indeed the exceedance of these realized shocks relative to what you could expected from a 5-year benchmark period before the supply chain relationship significantly, strongly, positively predicts the end of these supply chain relationships. The same is true if we look at, so this was the heat wave test. The same is true if I showed you the results for floods. Generally, again, the results here are stronger for floods compared to heat waves. We do a number of robustness checks here, again, looking at different ways of estimating this benchmark period, looking at different ways, instead of using a dummy indicator on the right, looking at continuous measures. And interestingly and importantly, we also find, consistent with this theoretical idea that I showed you before, that there's a negligible effect of the shocks themselves, not necessarily predicting the end of the relationships with the same significance. All right, and then we move on to sort of the last part of our analysis. What happens after these suppliers are dropped? If the customer still needs the same types of inputs, needs the same types of inputs in their production function, then likely they're going to move to a different supplier that can provide similar goods. And so what we do is we identify other firms that start a new supply chain relationship with the same customer in the following 2 years that is in the exact same SIC industry as the supplier firm for which the relationship just ended. And then we compare the climate exposure in the location of that previous supplier with the climate shock exposure in the location of that replacement supplier. So we're looking at this, first of all, looking at the replaced supplier, the one that was previously in the relationship during the period in which they were in the supply chain relationship, as well as the period after, and compare that throughout the same comparable period for that new supplier that entered a relationship. And the results sort of consistent with this interpretation that the customers move on to different new suppliers that have a lower exposure in terms of climate shocks, both for heat waves as well as flooding incidents. We find for the period during the relationship as well as after the relationship a significantly lower amount of climate-related shocks in the relationship in the location of the new suppliers. This is a simple sort of difference in mean test. We're working on updating the paper in this respect right now, and the results look quite similar when implemented in a more sort of a more precise and saturated econometric model. All right, so I think I'm pretty much out of time. So let me wrap up. In this paper, we do 3 things. We first of all show that indeed climate shocks and climate events related to heat waves and floods propagate through global supply chain networks, affecting the performance of not just the suppliers themselves, but also the customers, extending the findings in Barreau and Sauvagnat. We show that this has an impact on the likelihood that a supply chain relationship is terminated, especially when the occurrence of these events exceeds what could have been expected coming in. And we find that the replacement suppliers tend to have a lower climate change exposure relative to the ones that were just dropped. All right, thank you very much. I'm looking forward to the questions.
Thank you, Christoph. Yeah, and great. Let's jump into the questions because we have two out there already. So the first one would be a question by Curtis Walker from the National Center for Atmospheric Research. I think your affiliation is cut off here. I hope I went with the right full affiliation. So the question is, you presented the research questions with supplier versus customer impacts. Have you considered also thinking about the shipper? So air, rail, marine, pipeline, and road transport may have unique impacts. And could you comment on this?
Fantastic question. It's not really within the scope of what we're trying to do in this project. I think we're in this project limiting ourselves to this supply chain setting. But I think it's a very, very interesting way of thinking about the channels and mechanisms in which both heat waves and floods might actually cause these types of disruptions and financial impacts. I think in general, the literature has a relatively limited understanding of how these disruptions enter the performance of firms. And I think if we could shed some light on the channels and the mechanisms through which that occurs, for example, by disrupting shipping routes, by disrupting pipelines or other sort of infrastructure like that, as you suggested, that would be a super valuable contribution and very, very interesting. In the context of this paper, I think it's not within the scope of what we can do.
Great. One more question here by Rui Shi from Johns Hopkins University. And that question is, is the result sensitive to the definition of heat waves? And would that matter if we change to another heat wave definition? That's also a very good question.
Yeah, so fantastic question again. In the current version of the paper that I just presented, we're using sort of a relatively simple definition of heat waves that is quite commonly used in the literature. We're working on an update, on a revision in which we use a large number of different definitions, and the results are fairly robust and fairly stable. We're trying to sort of follow the literature on the physiological effects of heat, in the sense that we're looking at cutoff points at which we know that sort of human performance and ability to do cognitive tasks and things like that, for example, decreases. So those are the types of cutoffs we're looking at. But yeah, so from what I'm seeing, the effects are relatively robust across different definitions of heat, either using sort of relative heat wave definitions, comparing the local averages or the local distribution to the realizations, or just sort of absolute thresholds motivated by research on physiological effects of heat.
Excellent. And with that, I would say perfect timing to wrap up the session. So thanks a lot once more to, first of all, our collaborators for making all of this possible. A big thank you also to our three great speakers. And last but not least, also you as the audience. So I think we had like a lot of really, really nice questions here. And maybe once more, a note on if there's still anything that's on your mind, if you have comments or just remarks that came up during the presentation. I think I can speak for everyone that all of the presenters would be really grateful to hear from you, and you could simply reach out. I think we have all of the bios on the event website. Yeah, and apart from that, of course, we hope that you still stay with us a little bit longer. So next up, we have the second round of breakout sessions, and you see an overview here what we have going on in 4 virtual conference rooms. So again, it would be great to still have you with us for the rest of the day. Thank you very much for tuning in.